Hello, College Algebra. Hope you guys are doing all right. Before we start this lesson, I want to do a quick bell ringer. Let's say we have this rational expression, and we want to find out what makes the top 0 and then what makes the bottom 0. So let's first start with the top. So in other words, what we need to do is we need to take the top and set it equal to 0. And then we'll solve for x, and that will give us what we're looking for. So in other words, 2x minus 5 equals 0, and then we'll add 5 to both sides. So you'll get 2x equals 5. And then last thing you need to do is divide by the 2. So you'll get that x equals 5 over 2. So that is what will make the top 0. So 5 over 2. Then we're going to do the same thing for the bottom. In other words, we're going to take the bottom, set it equal to 0, and solve. Of course, this one will be easier. You just need to subtract 2 to both sides, and you'll get x equals -2. So for the bottom, if we plug in -2, that will give us 0 on the bottom. But now here's the question. Is it okay for the top or the bottom to be equal to 0? And some of you probably already know the answer to this, but let's just be careful. So let's say you have a fraction where the top is equal to 0, like 0 over 12. If you do 0 divided by 12 in your calculator, you'll end up getting 0. And that is a normal number, so that is totally okay. But what if, say, it was the other way around, where you had 12 divided by 0, where 0 is on bottom? If you put that in your calculator, 12 divided by 0, yeah, you're going to get calculator error, which actually means this is undefined. So we cannot have 0 be equal on bottom. Or more specifically, when you write this statement, you specifically have to say x cannot equal -2. Because if you were to plug in -2 into this function, you would get -2 plus 2 on bottom, which would give you 0. And as you saw here, 0 on bottom does not work. So in other words, the top, you can always have the top equal to 0. The bottom cannot. So whatever the bottom is equal to, you got to say it does not, just to make sure that you do not have any domain errors. That is something that we will be using a lot in this lesson. So I just wanted to clarify that before we continue. So with that said, now let's move on to the main topic. The lesson for this week will be 4.5b, Rational Inequalities. And this is going to be a 3-part lesson. So in other words, this is going to have 3 videos. Now, I will let you know, my personal opinion is that this is kind of the trickiest lesson in college algebra. So I'm going to be going over every single step as much as possible, every single detail as much as possible, and I strongly encourage that you write down every single step, every single detail, just so you don't make any tiny mistakes. The tiniest mistake will make the whole thing wrong, and then you'll have to start over. So, just want to let you know that. And that's why I'm separating this lesson into 3 short videos. So then you can have more, it'll be easier for you guys to focus on what you need to. So in other words, for this video, this is going to be the beginning. This is going to be part 1 of 3 videos. And 4.5b is covering rational inequalities. By definition, a rational inequality is still basically just a rational function. Like, for example, the function that you saw on the previous slide, that's a rational function, but with 2 differences. We're now going to take the rational inequalities and we're going to throw in inequalities. And also with those inequalities, we're going to have to find the interval solutions. Or in other words, we're going to be using interval notation, those open and closed brackets. So brace yourself, we're going to have to be doing that. So more specifically, what's going to be happening is you're going to be getting a type of function, and it's going to be set equal to 0. equal to 0. But specifically not equal to 0, it's going to be like greater than or equal to 0. It'll be less than 0 or less than or equal to 0, yada, yada, yada. And what's going to happen is you're going to have to find the intervals, like, for example, 0 to 3, and see, does that satisfy this equation? Does that give us all the answers where 7 over x plus 4 is less than or equal to 0? And you'll say yes or no. So, just to give you a synopsis of what's going to happen. We'll be given inequalities, we're going to be given intervals, and we need to say yes, it works, or no, it doesn't work. So, just going to give you a heads up on that. Now, on the next slide, I have word-by-word steps on how to do these. If you want to read through those, go ahead. But I feel like the best way to explain how to solve these is to just go ahead and show you. So, with that said, let me show you how it's done. So, let's say we have this rational expression, x minus 4 over x plus 4, and it's greater than 0. We need to solve this rational inequality and write our answer in interval notation. Or in other words, we need to find all the x values so that if we were to plug in x, the answer would be greater than 0. And this is usually the best way to do it. The first thing you want to do is take the top part of the fraction and then the bottom part of the fraction, set both top and bottom equal to 0, and solve for the x. So, in other words, let's go ahead and do the top. Take the top, set it equal to 0. So I'm going to do that up here, x minus 4 equals 0. You solve by adding 4 to both sides, and you'll get x equals 4. So go ahead and put that right there. For the top, x will equal 4. So in other words, if you plug in 4 on the top, you'll get 0. Now we're going to do the same thing on the bottom. So at the bottom, or in this case, x plus 4, set that equal to 0 and solve. Very similar to the first one, and you're going to get that x is equal to negative 4. Now, remember what we talked about on the very first slide, that the bottom cannot equal 0 because that'll give us a domain error. We got to do the same thing on this example, that x cannot equal negative 4 on the bottom. That will prevent domain errors. So that's the first step, figuring out what the top and the bottom numbers are and labeling them accordingly. Step 2, we need to determine if the top number and the bottom number, what type of brackets are they going to need? Well, I'm going to let you know for the bottom is always going to be open brackets, specifically because of this. Since x can never equal negative 4, that's why we can only use open brackets for the bottom. If we used closed, we'd be saying that it could equal negative 4, which we do not want. The bottom will always be open brackets, no matter what. The top can either be open or closed depending on the inequality sign. So in other words, you got to look at the inequality sign, and that will tell you which one we need. And specifically in this case, if it's strictly less or strictly greater than, it's going to be the open brackets, not the closed. So we're going to say here, we're going to have open brackets at 4 and open brackets at negative 4. Okay, so that's step 2. The third step is we're going to go to the real number line, graph the information we have, and then we're going to find some test values to plug and chug. I'll show you what I'm talking about in a moment. First thing we want to do, let's take our top number of 4 and place it on the real number line. So the top value, we got that x is equal to 4, and we also have it's going to have open parentheses. So let's go ahead and just put open parentheses around the 4. Okay? Now, let's put the bottom of negative 4. And since we said it's not equal to negative, it's specifically not equal to negative 4, and it has open brackets, that's why we're going to put open brackets around that as well. All right. So now that I have the 4 and the negative 4, you'll notice that I have 3 intervals. 1, 2, 3 intervals. And what's going to happen with each interval is I'm going to pick a number from each of those intervals, and I'm going to plug it in to our equation, or specifically our inequality. So I'm going to plug and chug, and if it turns out I get a good answer, that interval will be part of the answer. If not, the interval, we're going to leave it out. So again, I'll just show you what I'm talking about so it makes a bit more sense. So for this interval, I'm going to pick a test value to plug in. Like for example, I'll pick -7 within the first interval. The second interval, I'm going to pick test value, or TV for short, I'm going to pick 0. And I'll be plugging in 0 for that interval. For this interval, I'll pick a test value of 5. So basically, I picked a number inside each of the 3 intervals. I'm going to plug each of those numbers in to our inequality and see what happens. And let's just look at what our inequality is. We have x minus 4 over x plus 4, and that's going to be greater than 0. All right. So now we'll take that equation and we'll plug in our test values from each interval. The first number I'll plug in is -7 for this interval. So instead of x minus 4, I'll do -7 minus 4. Instead of x plus 4, I'll do -7 plus 4. And we'll go from there. -7 minus 4 on top will give you -11. -7 minus 4 on bottom will give you -3. And of course, a negative divided by a negative gives you positive on top and bottom. So we end up getting 11/3. But now here's the question. Is that greater than 0? Our inequality, sure enough, 11/3 is greater than 0, which is good. Which means this interval we get to shade in as our answer. So that interval is going to be part of our answer, and that's why we shaded it in. Now let's do the same thing for the second interval. We'll take x minus 4, x plus 4, and it's greater than 0, and we're going to plug in 0 this time. So now, instead of x minus 4, we'll do 0 minus 4, and on bottom, x plus 4 will be 0 plus 4. On the top, you'll get -4. On the bottom, you'll get +4. Simplify that, that gives you -1. But is that greater than 0? And sadly, -1 is not greater than 0. That is a false statement. So in other words, this interval is out. It's not part of our answer. All right, 2 intervals down, 1 more to go. So now I'm going to do x minus 4, x plus 4, still greater than 0. And this is going to be the last test value to try. We'll plug in number 5. So I'm going to plug in 5 minus 4 on top. On bottom, we'll have 5 plus 4. Go from there. 5 minus 4 on top will be 1. 5 minus 4 on bottom will be 9. And that just leaves us with 1/9. And is 1/9 greater than 0? It sure is. 1/9 is greater than 0. So this test value worked. So thus this interval is part of my answer. Okay, now we have tested each interval. We have shaded what worked and crossed out what is not. To show you how to get the final answer, I'm first going to erase the work, but you guys should already have that written down. Erase the work. Okay, so for our answer, let's look at what we shaded. The first thing we shaded was this interval. And if you look, this interval goes from -infinity all the way up to where our shading stopped, which was at -4. So in other words, our interval is from -infinity to -4. Because that's where we shaded, -infinity all the way to -4. But now the intervals, or in other words, open or close brackets. Well, you know infinity, no matter what, always gets open. The -4, if you look here, we had put an open parentheses at -4. So for our answer, we'll have an open parentheses there. So that's the first part of our answer. But now let's look at our second interval that we shaded. And it looks like it goes from 4 all the way to positive infinity. So for that interval, we're going to go from 4 to infinity, because that's where we shaded, right here at 4 all the way to infinity. Now what about the open or closed brackets? Infinity will always get open. Positive 4 looks like we put open parentheses, so we put open parentheses there. So those are our two intervals in interval notation. And the last thing you need to put is that since we have two intervals, you just have to put a union symbol. And that is what you'll put into the Hawks program. Basically, this interval describes every single answer that we can plug in into this equation and have it greater than 0. So there you have it. That's how most of these problems are going to be for 4.5b. You'll take the top and bottom, set them equal to 0, figure out what bracket to use, then you'll use a real number line and use test values, plug and chug the test values to find your answers. And we'll do a few more in this video just so you can get familiar with it. And then you'll have a nice introduction of what we're doing for this lesson. So let's go ahead and try another one similar to that. So now we have x plus 2 over x minus 2, and it's less than or equal to 0. And we're going to find all the solutions that make this inequality true. So starting with the first step, we need to take the top part and the bottom part and set them both equal to 0. Okay, if we go to the top, set the top equal to 0, solve, you're going to get x equals -2. Really easy. Now, do the same thing for the bottom. So take the bottom part, set it equal to 0, solve, and you're going to get x equals +2. But remember, bottom can never equal 0, so that's why you have to put strictly x does not equal. And since it does not equal 0, you can always assume that since it's never equal to 2, that it's going to have open parentheses. Always, always, always for the bottom part. So that actually is a nice introduction to part 2. What bracket do we need to use, open or closed? And well, we already figured out what we needed for the bottom. Let's figure out what we need for the top. And remember, the top is going to depend on what inequality we're working with. And since we're working with less than or equal to, the equal sign means we have to use closed brackets. So we're going to have closed brackets specifically for the top, open brackets for the bottom. Yes, you can have different brackets for top and bottom. That's perfectly okay, just so you know. All right, so that's step 2. The third step is we're going to graph the information we have. Then we're going to find some test values, or TVs, plug and chug to find our answers. All right, so let's do that part. So first I have my top. I have my top right at -2. And -2 is going to have open brackets. So or not open, I meant closed. We're going to have closed brackets at -2. That's what I meant to say. There we go. Then for the bottom, we have +2. And it's going to have open parentheses at +2. So just going to go ahead and draw those. Now we have our 3 intervals. We got interval 1, interval 2, interval 3. So let's go ahead and pick test values for each one. For this one, I can pick -10, -9, -8, any one of these, as long as it's not the blue line of -2. So don't pick that one. I'm going to go ahead and pick -4. Let's be -4 be our test value. In the middle, I got to pick -1, 0, or 1. I'm going to go ahead and pick 0 because that one's an easy one to plug in. And then for the third interval, I can't pick 2 because that's the blue border, but I can pick 3, 4, 5, 6, 7, 8, 9, yada, yada, yada. I'm going to go ahead and pick 3. So test value of 3. All right. So we got our 3 test values. Now we just got to plug them into our equation, where our equation is going to be x plus 2 all over x minus 2, and it's less than or equal to 0. All right, let us begin. So let's check out the first interval where I'm going to try plugging in -4. So on top, I'm going to have -4 plus 2. On the bottom, I'm going to have -4 minus 2. Simplify from there. On top, you'll have -2. On bottom, you'll have -6, which negative divided by negative makes that plus positive, and 2 6 simplifies to 1/3. But now, is 1/3 less than or equal to 0? 1/3 is not less than 0. If it was negative, we'd be good. But that is not a true statement, so that interval is not part of our answer. Moving on to the second interval. So I still have x plus 2, x minus 2 as my inequality, and it is not greater than, it is less than or equal to 0. And I'm going to do some plug-in chugging this time, where I'm going to plug in 0 this time. So now I'm going to have 0 plus 2 on top, 0 minus 2 on bottom. So I'll get 2 on top, -2 on bottom, and that simplifies down to -1. And is -1 less than or equal to 0? Negative is less than 0, so that's a true statement. So the second interval is part of our answer, so we're going to shade it. All right, one more interval to try out. So I got to do x plus 2, x minus 2, and that's going to be less than or equal to 0. And I'm going to try plugging in 3 to see what happens. All right, so on top, it's going to give me 3 plus 2. On bottom, it's going to give me 3 minus 2. So on top, I'm going to get 5. On bottom, I'm going to get 1. And, well, 5 divided by 1 is 5. But is that less than or equal to 0? 5 is not less than 0. So that's a false statement. So the third interval is out, not part of our answer. Okay, we've tested each of the intervals. So now let's erase our work and let's see what our answer is. So it looks like we only have one interval that passed. Everything in between -2 and 2. So -2 and 2 is our interval. And let's see what brackets we need. 2 has an open bracket. -2 has a closed bracket. And in this case, since we only have one interval, we don't need a union. We only got one interval as our answer, so no union, you're done. -2 to 2, closed bracket on -2, open bracket on +2. And there you go. So sometimes you'll have to use the union symbol, sometimes you will not. It will all depend on how many intervals you get to work. In this case, we only got one interval to work, so we don't need a union. And that's it. We'll do a few more just so you can get the hang of this, and that will be a nice introduction to 4.5b. And then videos 2 and 3 will cover some other stuff. So here we have x minus 5 over 5x, and it's greater than or equal to 0. And again, we're going to find the intervals that make this true. So step 1, as always, take the top part, take the bottom part, and set them equal to 0. So we're going to do it for the top. Set the top equal to 0, and you're going to get x equals 5. Now we're going to do the same thing for the bottom. For the bottom, we got 5x, and when you set, I'm going to do it over here. When you set 5x equal to 0, now this time it's a little bit different. You're not going to be adding or subtracting that 5. Since the 5 is being multiplied, the opposite operation would be to divide it. So then x is going to be equal to 0 divided by 5. And 0 being on top, that works. And 0 over 5 should just give you 0. So that's what we're going to get for the bottom part, that x is equal to 0. But of course, it is the bottom, so we got to put does not equal. X cannot equal 0 on bottom. And of course, because of that not equal sign, again, always, always, always open parentheses for the bottom. So that one's a little bit different. You weren't adding or subtracting this time. You had to divide that 5, which would give you x equals 0. Gotta be careful on those. Okay, so now moving on to step 2, we gotta determine, Now to step 2, we gotta determine if we're open or closed. Bottom, we already said was open. The top will be determined by the inequality. And since the inequality has an equal, that means we have closed brackets for the top. So that takes care of step 2. Now we can move on to the third step, where we're going to graph the information we have and find some test values to plug and chug. All right, so let's first graph the top, where the top is right at 5, and it's going to have closed brackets around 5. All right, looks good. Now we got to do the bottom. The bottom is stationed at 0 with open parentheses. So open parentheses around the 0. And with that, we have the graph. Now we just got to find our test values. For the first interval, I can't pick 0 because it's on the blue line, but I can pick any of these. I'm going to pick the easiest one, and I'll let my test value be -1. For my second interval, I can pick 1, 2, 3, or 4. Again, probably the easiest thing to plug in would be 1. And then for the third one, I can plug in 6, 7, 8, 9, 10, or so on. I'm going to let my test value be 6. So those are the 3 test values I'm going to pick to plug and chug. Give me a second, I'm going to grab a cough drop. Okay, I'm good. All right, so let's plug in some values. All right, so the equation we're going to be working with is this one. X minus 5 over 5x, and it's going to be greater than or equal to 0. All right, so let's do some plugging and chugging. First value I'm going to plug in is -1. So I'm going to have -1 minus 5 on top, and on bottom we have 5 times -1. And let's see what that gets us. On top, -1 minus 5 will be -6. 5 times -1 on bottom will be -5. And of course, a negative divided by negative makes that plus positive. So 6 over 5 is our answer for that, but is that greater than or equal to 0? 6 over 5 is positive, and any positive number is bigger than 0. So that is a true statement, which means our first interval works. So we're going to shade in that first interval. All right, moving on to interval number 2. I still have x minus 5 over 5x, and it's greater than or equal to 0. And this time I'm going to plug in 1 and see what happens. So I plug in 1, I'm going to get 1 minus 5 on top. On bottom, I'm going to get 5 times 1. 1 minus 5 on top will give you -4. 1 times 5 on bottom will give you 5. So -4/5. But is that greater than or equal to 0? A negative number is not bigger than 0, so that's a false statement. So in other words, the second interval is out, not part of our answer. All right, one more value to try. Again, I'm using x minus 5 divided by 5x, all greater than or equal to 0. The last number we're going to try is number 6. So let's plug in number 6. On top, you'll get 6 minus 5. On bottom, you'll get 5 times 6. 6 minus 5 on top will give you 1. 5 times 6 on bottom will give you 30. And is 1 over 30, is that greater than or equal to 0? 1 over 30. Though it is small, it is positive, and any positive number is bigger than 0. So that is a true statement, which means the third interval is part of our answer. So we get to shade it in. All right, we've tested all 3 intervals. Now let's erase what we have so we can write down our final answer, or erase the work. You don't have to erase the work, I'm just erasing it so you guys can formally see what I'm about to do. All right, so our first answer we shaded goes all the way from negative infinity all the way up to 0. So negative infinity comma 0 is our first interval. And we're going to have an open on negative infinity because infinity also is always open. And at 0, we have a green open parentheses, so it will have open as well. Now our second interval, we shaded from 5 all the way to positive infinity. So 5 to infinity is our second interval. For the open or closed, infinity, always open. 5, we have closed brackets here, so that's going to be a closed bracket. And of course, we got 2 intervals as our answer, so you put a union symbol in the middle, and you have your Hawks answer, just like that. All right, so that one was a little bit different. That's specifically because the bottom was not plus or minus 5. It was 5 times x, which made it different for what we get for the bottom. That was probably the only thing that was really different about that one. So just make sure you're being careful with those problems, and you should be fine. Let's try another one similar to this. So here we got 3 times x. Again, it's not being added or subtracted. The 3 is being multiplied this time. So 3x over x plus 5 less than 0, and we need to solve it. Just like we've done before. First thing we're going to do, take the top, take the bottom, set them equal to 0. So let's take the top. In other words, take 3x, set it equal to 0. So 3x equals, I'm not going to do it there. 3x equals 0. You need to divide by 3, because 3 is multiplying. The opposite operation would be to divide. So then x is going to be equal to 0 divided by 3. 0 on top is okay. So 0 divided by 3 gives you 0. So x equals 0 is what you get on top. All right? Now, do the same thing for the bottom. Take the bottom, set it equal to 0. That's x plus 5 equals 0. Solving that is easy. You get x equals negative 5. And as always, the bottom, you cannot have it equal negative 5. And since it is not equal, you can always assume that it's going to have open parentheses. Always, always, always. The bottom will always be open parentheses. Which moves us on to the second step. Do we get open or closed? Again, we already took care of the bottom. Top will depend on the inequality. It is strictly less than or strictly greater than, so which means it is also open parentheses this time. Okay, so that takes care of part 2, easy peasy. And now we can move on to the third step, where we graph the information we have, find some test values to plug and check. All right, let's first graph the top. The top we have right at 0, and its parentheses are open. Now let's graph the bottom, where the bottom is at negative 5, and it also has open parentheses. Oops, did not draw that well. Whoop, much better. All right, so we now have graphed the information we have. We have our intervals. Now we can pick our test values. For the first interval, I can pick any of these numbers. I can't pick negative 5 because that's part of the blue border. I'm going to go ahead and pick negative 6 as my test value. For the second interval, I can pick negative 4, negative 3, negative 2, negative 1. I'm going to go ahead and pick negative 1 because that's easy to plug in. For the third interval, I can pick any of these numbers. And I'm going to pick the easiest one, test value of 1. All right, those are the 3 values that we're going to test, and we're going to plug them into this inequality. So in other words, 3x all over x plus 5, and it is less than 0. All right, let's plug it into -6 for the first interval. So on top, we're going to have 3 times -6. On bottom, we're going to have -6 plus 5. Simplify. On top, we're going to have -18. On bottom, -6 plus 5 is -1. Negative divided by negative makes it plus positive. So 18 over 1 is just 18. But is 18 less than 0? Sadly, 18 cannot be smaller than 0. That is a false statement. So the first interval is out of our answer. All right, interval number 2, 3x divided by x plus 5, still less than 0. This time I'm going to plug in -1. So let's do it. 3 times -1, and on the bottom you'll have -1 plus 5. Go from there, top you'll get -3. On bottom, 1 plus 5 will give you 4. So -3/4. And is that less than 0? -3/4 less than 0 is true, because the negative is smaller than 0. So the second interval passes, and we're going to shade it as part of our answer. One more interval to test out. So again, one last time, 3x over x plus 5, and it is less than 0. And the value I'm going to plug in, test value of 1. So on the top, we're going to have 3 times 1. On the bottom, I'm going to have 1 plus 5. Simplify. On top, I'm going to get 3. On bottom, I'm going to get 6. And 3 divided by 6 is going to give me 1/2. And is 1/2 less than 0? It is not. 1/2 is not less than 0. So the third interval fails. All right, we've tested all 3. So I'm going to erase the work so you can see what the final answer is going to become. All right, so we only one interval worked. So everything in between -5 and 0. So -5, 0 will be our final answer. And for the open or closed, 0, we have an open, and at -5, we have an open. And since that's the only interval, we don't need a union, so that's our Hawk's answer. -5, 0, open parentheses, just like that. Now, I do want to point something out. You probably noticed by now that for our answers, they always seem to alternate. So like at the first one, remember, look at the shading. We got true, and then false, and then true. Like not once did we get like 2 trues at the same time. So in other words, if the first one is true, you can assume the second one's going to be false, and then the next one's going to be true. You will always be alternating. You will never have 2 answers where it's you have 2. It's never going to be that you're going to have 2 true intervals or correct intervals right next to each other. They're always going to be alternating. So in other words, true, false, true. Then here we got false, which means the second one had to be true, and then the next one had to be false. They will always be alternating. Same thing on the third one. This one turned out to be true, this one was false, this one was true. Again, alternating. And same as the last one. The first interval turned out to be false. Second one true. Last one false. So I'm not saying you should stop plugging and chugging. I'm saying that once you're done plugging and chugging, make sure that your answer alternates. So in other words, there should never be 2 trues next to each other, and there should be no 2 false intervals next to each other. They should always alternate. You should always double check your work. Okay? But yes, that will help you a lot on the Hawks program. Your intervals will always alternate for this lesson. Okay, so a couple more examples when we're done for this video. Again, let's do the same thing we've always done. First step, you'll take the top and the bottom, and you set it equal to 0. So for the top, you set it equal to 0, you're going to get x equals 7. And then for the bottom, take the bottom, set it equal to 0, you just get 3 equals 0. Where's my x value? What is x going to be equal to? X equal to 3, x equal to 0? There is no x value. You just get 3 equals 0, which 3 cannot equal 0. So in other words, you don't really have anything for the bottom. That's it. You don't need to do anything for the bottom. The only thing you have is the top. So in other words, you've done the first part. Now you can move on to the second part if we're going to have open or closed. And for the top, got to look at the inequality, and it is greater than or equal to. Equal to means closed. So that takes care of part 2, really easy. Now we can move on to graphing the information we have and picking test values. So again, we didn't have anything for the bottom, because if you set the bottom equal to 0, you get 3 equals 0, and that's a false statement. So the only thing we have is for the top. The top we have equal to 7, and it's going to have closed brackets at 7, so closed, closed. And then from there we can pick our test values. And notice this time we only have 2 intervals. We have this interval and this interval, which actually means less work for us to find the answer. So I'm going to pick a test value in here. I can pick any test value I want on this side. I'm going to pick the easiest one, which is 0. 0 is the easiest thing to plug in. For the second interval, I can plug in 8, 9, 10, or anything above. I'm going to go ahead and pick 8. I'll plug in 8 as a test value. All right, so let's plug in these test values into our equation. And our equation is this. X minus 7 all over 3 greater than or equal to 0. All right, so give me a sec. Just settle things up. Okay. All right, so let's plug in our first test value. Let's plug in 0. So we're going to get 0 minus 7 over 3. And on top, that's negative 7. On bottom, that gives you 3. But is that greater than or equal to 0? A negative number cannot be greater than 0. That's a false statement. False statement on the first one. Miss Shulin, does that mean since my answer need to alternate, can I just instantly assume the test value is true for the second one? To be honest, I would rather that, just to be safe, I would rather that you still plug and chug. Because who knows? You might have messed this up. So it wouldn't hurt just to go ahead and test everything. Just to be safe. So x minus 7 all over 3 greater than or equal to 0. Now we're going to plug in 8. So plug in 8, so you'll get 8 minus 7 over 3. 8 minus 7 is 1 on top. You still get 3 on bottom, so you just get 1/3. And 1/3 is greater than or equal to 0, so that is a true statement. Again, I might have made a mistake. I might have gotten true for the first one and false for the second one, which might have messed up the entire problem. Or you might have gotten 2 trues, which means, ooh, I might have messed up on 1. Or you might have gotten 2 false. So my advice is still plug and chug. Still plug and chug everything you can, and then see if your answers alternate. And if they alternate, that means most likely you did the work right. Okay. I just wanted to make that clear. That's one of the main things that students mess up on this, and that's why this lesson is so hard, is because students want to rush. They want to rush this and just get it done, but the rushing makes it worse because you keep getting it wrong. So with that said, we've double-checked, we're alternating, where this is false and this is true. Then this would be the true interval. So everything from 7 to infinity. So 7, infinity. When the infinity gets open, and the 7, as we see here, gets closed. So from 7 to infinity. No union symbol because we only had one interval. Okay. So how about you try this one on your own? Go ahead and try it. Make sure you do every single step. You plug and chug every test value. Make sure it alternates, and then write your final answer. Go ahead and pause the video and try it now. All right. You should have resumed the video by now. If you want to go ahead and check your answer, if you already have it, your answer should be -5, infinity, and you should have open parentheses for both ends. That should be the answer you got. And if you got that as your answer, awesome, you're feeling pretty good, you can go ahead and move on to the second video, part 2. If you're not sure how I got this answer, I'm going to go ahead and work through it, so you can pay attention to the last part. So, for here, again, first thing we're going to do, we're going to take the top and the bottom, set it equal to 0. Now for the top we have 5 equals 0. There's no x to solve for, and it doesn't make sense that 5 is equal to 0. That does not make sense. So we're going to put none there. But we still got a bottom to deal with. So in other words, we take the bottom, set it equal to 0. You get x plus 5 equals 0. Solve, and you'll get x equals -5. But as always, the bottom, you got to make sure it's not equal to. And since it's not equal to, we can always assume, no matter what, that it's open, no matter what. And, of course, that already takes care of step 2. We don't need to determine if it's open or closed, because we don't even have a top. And the bottom, always open. Didn't even need to look at the inequality, because we can always assume the bottom is 0. Which means we can go ahead and move on to our third step, which is to go to the graph what we have, and find some test values. Let's do it. Again, we don't have anything for the top. We only have a number for the bottom, where the bottom, we got that the number is -5, and as always, open parentheses. So our test values, we can pick anything for this side. I'm going to go ahead and pick a test value of -6 on this side. I can pick anything on the right side for the second interval. And I'm going to pick 0 because that's the easiest thing to plug in. All right, so those are test values. And we're going to use this function to solve. So x all over x plus 5, and it is greater than 0. So from there, we'll plug in our first value of -6 and see what happens. So in other words, 5 stays 5 on top. On bottom, we'll get -6 plus 5. Simplify, 5 on top, -6 plus 5 is -1 on bottom, and that simplifies to -5. But is that greater than 0? -5 cannot be bigger than 0, so that interval fails. Now let's try the second one just to see what happens. So 5 over x plus 5, it is still greater than 0, and now we're going to plug in 0 to see what happens. So on top we get 5, on bottom is 0 plus 5. On top you get 5, on bottom you get 5, and of course it simplifies down to 1. And 1, is that greater than or equal to 0? It is not. Oh, no, we'll scratch that. I lied. 1, is it greater than 0? 1, of course, is bigger than none, so that is a true statement. So this interval we can shade as our correct answer. Okay, we tested each of the 2 intervals. So now we can formally write down our final answer. Our final answer starts at -5 and shades all the way to infinity. So -5, infinity. In infinity, we'll get the open. The -5 will also get open. So that's how we got our answer, -5 to infinity. Okay, that was just an introduction to the type of problems we're going to be coming across. Part 2 and Part 3 will cover some special examples that will also be covered in 4.5b. But if you feel pretty confident on these, the next 2 videos won't be so bad. So go ahead, take a break, and whenever you're ready, start video number 2.